today is look at our current European specifications for bitumen. If you remember way back when we started this webinar series, we had a session on a global overview of specifications. Today we're going to just refresh everybody's memories with regards to current European specifications. Then we're going to have a look at EUB3465's positions and what it's done on the subject of specifications over the years. And then we'll end with a closer look at the work of EUB3465's task force specifications, which has done a lot of work over the last few years on where we feel as EUB3465, an organisation, should go with specifications, and that reflects the views of all of our members. So in terms of European specifications, first thing we have to think about is how everything fits together. With anything that deals with specifications, we have a legal part of the specification and we have a technical part, and we're driven by the Construction Products Regulation, or historically driven by the Construction Products Directive. Once a directive becomes regulation, it then becomes part of European law and part of law of European member states. So that's our legal part. That's what drives the development of specifications. As a result of the Construction Products Regulations, the European Commission then sends a request to CEN, the European Committee for Normalization or Standardization. And that's called a mandate. And it requires CEN to develop a set of test methods and performance indicators that deal with the certain requirements in the Construction Products Regulation. And from that then comes a harmonized product standard. And that means those standards, in our case, bitumen, there is no difference across the whole of the European member states. We're all dealing with exactly the same things, exactly the same parameters, the same materials. So it allows complete freedom of trade. And it's very important that happens. So how do we get there? Well, for anyone who's been involved in the process, I have over the last 20, 30 years, so has Anja Sørensen. It starts with individual member states coming together and sharing their national specifications. And then after a period of time, we end up with consensus, and that gives us a harmonized specification. And then it becomes a harmonized specification, which goes across the whole of Europe. Once the specification is published, we don't leave it there. It is subject to what's called a 5-year systematic review. So every 5 years, we look at the specification and decide whether or not it needs any changes. And sometimes it does, and sometimes it doesn't. So that's effectively the process. It might seem funny that when I'm going to talk about future specifications, I start with a look at the past. But those of you that know me know that I'm a fan of history. Historical developments interest me. So how did we get to our European specifications? Well, I've touched on it a little bit already. But in 1999, the very first common European product standard for bitumen was published, and that's EN12591, the specification for paving grade bitumens. How did we get to it? Well, as I said, the individual member states sit around a table, put forward their proposals, and eventually we arrive at a consensus. We also have input from individual CEN members, and we arrive at this harmonized specification. What does 12591 look like? Well, I'm sure you all know and you all understand. It's based on conventional, or what we would call empirical specifications. And it's in a classical table format. We read the properties down an individual column and they apply to that particular grade of bitumen. It has individual tables in it for bitumens that are graded either by penetration or viscosity. And it contains, rather peculiarly for a harmonized standard, mandatory properties and some regional requirements that apply to individual countries. So let's just have a little look at it. There we are, a classical format for bitumen specifications. The properties are of the individual grades are arranged in columns, and I've highlighted there 5070, a pretty standard grade across the whole of Europe. So 5070, our penetration is 50 to 70, ring and ball softening point 46 to 54, properties after aging, etc., etc. And we follow those individual properties in the first column all the way down, and that's the mandatory part of our specification for 5070. All of those properties need to be reported. But then there's another part to it, which for the first table 1, we have table 1A, which is the mandatory part, and then table 1B, which is the optional part, or the regional part. So these are properties that are applicable in individual member states. So they're things like penetration index, dynamic viscosity, press breaking point, kinematic viscosity. Now, those don't apply to every European country. Some countries pick certain properties from table 1B and some choose not to. The important thing to remember with this is that those properties, again, they fall in a column. So we read down the column of 5070 all the way through, and we pick the properties that are applicable to us depending on which member country we are in. And there's a little note at the bottom of table 1B which says those properties are required to meet specific regional, that's national, conditions and are associated with regulatory or national requirements. And that creates for us a little bit of a problem, and I'll come on to why that is a problem a little bit later on as we go through. So that's our specification for paving grade bitumen, and it's unique in a way when we look at all the other specifications for bitumen, because it's arranged in that classical vertical format. So you read all of the properties from top to bottom to get the specification for any individual grade. If you look at all the other specifications for bitumen and bituminous binders, they don't follow that classical vertical format. They're what we call framework specifications, and the most relevant one to us as members here today is 14023, the specification framework for polymer modified binders. And it's important that we understand the difference between the specification as written in 12591 to a specification framework as written in 14023. So what does it look like? Well, 14023 is different. We don't have individual grade designation in columns. What we have is a set of individual classes for different properties. So we have classes of penetration, and you can see going across that across the row from 1040 up to 200 to 300. We have classes for softening point starting at greater than or equal to 80 down to greater than or equal to 40, and the same for cohesion as measured by force ductility. So with our framework format, as we have in 14023, it's important to what this allows us to do is to put all of the different types of polymer modified bitumens all the way across Europe into a single table, and we decide the individual classes. So we pick a penetration range which is valid for our product, we pick a minimum softening point range for our product, and then we pick a cohesion value. I've just highlighted 3 particular properties. So there in the table where I've highlighted, you can see for PMB number 1, we have a penetration range of 25 to 55, a softening point that's greater than 55, and a cohesion value of greater than 2 joules per centimetre squared at 10 degrees. In red is PMB2, which has penetration range of 40 to 100, softening point greater than or equal to 80, and a cohesion greater than 3 at 5 degrees. But it just allows us to classify our products using a common framework. 2 things that inexperienced people tend to do with framework specifications is, firstly, then they will look at the table and try and read it vertically, and I've been asked in the past for a class 2 PMB. Well, a class 2 PMB doesn't exist, and I've seen people say that to use it as a wish list, or like a color chart that we use when we're painting and decorating, and they will say, well, I would like a class 7 for penetration and a class 3 for ring and ball softening point, but then I want a class 11 for force ductility and cohesion. And it doesn't work like that. It was never meant to work like that. So it's not a color chart, and it's not a vertical classical specification. It's important that we remember that, because that helps focus the way that we want to develop in the future. So what's happening with regards to development of specifications across Europe? Well, the single most important thing is the Construction Products Regulation, which is now being revised. A very long process with a lot of input from member states. European members have played an active role in putting forward proposals for what the construction products excuse me, what the Construction Products Regulation should look like. Why is it being revised? Well, the feeling is that the current Construction Product Regulation doesn't quite do what it was established to do, and that's establish harmonized specifications across Europe, remove barriers for trade, not be economically restrictive for any individual member state. Excuse me just a second. So that's being revised, and the first draft is through. It's under discussion at the moment by the European Parliament, the European Commission, and the Council of Europe in a process called the trilogue. That will end sometime in 2024, and then we hope that we will get a revised draft of the Construction Products Regulation, and then we can move forward with our specifications, because at the moment we can't. All product specifications and standards are frozen because of the revision to the Construction Products Regulation. And that's a difficult position to be in, because we want to develop new specifications that more accurately reflect the performance of the binder in the construction works. So that's the bitumen in an asphalt or in a waterproofing membrane or a roofing felt. What we do have is a process called CPR Acquis, and that is designed to bring existing harmonized standards into line with the construction products regulation, because some of them don't. And we expect that process to start for our bitumen specifications in late 2024, and the process will take around 1.5 to 2 years before we can then propose to the European Commission a new version of our bitumen standards, and then we have a process of putting those standards together and getting them published and harmonized, and that we expect to end sometime around 2030 with our new standards. What will most likely happen is those regional requirements that we had in the main body of EN12591 will disappear. So they will form part of a voluntary annex, if you like. So we won't have those specific regional or national requirements in the main body of the standard. It's very, very important for an organization like EUB3465 to have a voice, and our members to have a voice in that process, because once it starts, then we are under pressure to develop, firstly, what's called the new standardization request, which drives the development of specifications, and then the specification. So it's very, very important for an organization like EUB3465 to have a voice, and for its members to have a voice in that process. And it's critically important that we're involved early, and we make a communication of our positions early, because if we leave it, the chance will disappear. Everyone acknowledges that developments are necessary for product specifications. Why? Well, because right at the start I said our specifications are based primarily on empirical tests. They don't really reflect the performance of the binder in use. So we need to move towards performance-based assessments. How can we do that? Well, we can identify key characteristics that indicate those performance, the performance in the construction works. We can look at the critical aging stages, because currently our specifications stop at short-term aging. They stop after RTFOT. Well, as we know, bitumen has a life after the asphalt mixing plant. It has a life in the pavement or the roofing felt or the waterproofing membrane. So it's important that we consider things like long-term aging, and also that we look at the best available test methods to indicate that, because time has moved on. When EN12591 was published, I think it's fair to say that rheological assessments were in their infancy in the bitumen world. But we've developed an awful lot more since that, since 12591 was published. So there is a case for including performance-based test methods within specifications. What's EUB3465 done to back this up? Well, it has published data collection exercises. Excuse me. The first of which was done in 2009, and then followed up again in 2021. One of the critical outcomes from that was the simple versus complex binders concept. What does that mean? Well, the simple tests we found don't really describe the performance of polymer modified bitumens. They don't describe that performance adequately. So we have a preference for inclusion of rheological tests within specifications. We also felt that long-term aging should be considered, and that we should declare values for these rheological tests. So I'll just remind you of one of the one of the critical outcomes from that 2009 data collection exercise was this simple versus complex binders concept. And there we decided that for unmodified binders, which we term simple, that conventional tests such as penetration, ring and bore softening point, they were more or less okay to describe the performance. However, when we get to polymer modified bitumens, what we find is that they are inadequate. And so complex tests, rheological tests, cohesion tests, etc., they describe the performance of PMBs much better than an empirical test ever could. Then in 2017, we established task force specifications, and primarily at the time that was there to monitor developments and have an input into the revision of EN14023, that framework specification for polymer modified bitumens. It reports to the technical committee, and it has terms of reference, as do all of our committees and task forces, and it has some deliverables, some key deliverables. First off was to consider the options for EN14023 and to consider the next steps for 12591 paving grade bitumen specification. A very important deliverable for task force specifications is to develop clear positions that our members can communicate into SEN TC336 mirror committees. It's very, very important that that EUB3465 has a voice in that standardization process, and the only way we can do that is via our members communicating common positions within national mirror committees. And also an output is to look at the work that TC336 task group 14, which is also looking at future specifications. We need to monitor what is happening there. We've got a lot of expertise on that panel. Where our chair is Maria Gonzalez from CEPSA, and we have members from all of the bitumen companies, some modifier suppliers, and myself as technical lead, and Anja Sorensen as the HSE lead, but also because of Anja's experience in standardization. So what has task force specifications been doing? First of all, it's decided that really a specification should assess or indicate the performance of the binder in the construction works. So that's the asphalt, it's the roofing membrane or the waterproofing membrane. We need to address the performance when that material is in service and what the binder contribution is. We believe that there should be a single specification that's applicable to all binders. I would say probably just to add a little information to that, it's more relevant to us for, shall we say, conventional binders, not binders that are emulsified. They're not, strictly speaking, within our scope. And we have focused on some critical performance attributes, if you like. Resistance to permanent deformation, resistance to thermally induced cracking, raveling, and then also we've looked at some other parameters which are important in terms of performance, and that's stiffness and durability. And over the next few slides, I'm going to take you through the outcome of this work. And I will start with permanent deformation. You can see from the image on your screen there's a section of asphalt which is severely deformed. Why does an asphalt deform? Well, if we look at the characteristic that's associated with permanent deformation, it's flow. Really, it's flow of the binder. The binder can flow under certain conditions. It can behave in a viscous nature under certain conditions. Test work specifications have spent a long time looking at permanent deformation and all of those other characteristics that I mentioned. And after some discussion, the position within task force specifications is that the best test to indicate permanent deformation is the multiple stress and creep recovery test, EN16659. And the parameters that we would like to see included in a specification are the non-recoverable compliance, the JNR value, and the percentage recovery. We have looked in depth at the test method, the multiple stress creep recovery test method, and we believe that it's only really appropriate to record that JNR and percent recovery values at a stress level of 3.2 kPa. As you know, in the test method, it talks about carrying out an assessment at 0.1 kPa and another one at 3.2 kPa. Feeling amongst our members is that 0.1 kPa stress level doesn't really do anything. We'd be far better focusing on a stress level of 3.2 kPa. When does permanent deformation become a problem? Well, most typically early on in a pavement's life. So we believe that the most critical aging state to assess permanent deformation is on short-term aged binder. And it should be assessed in the temperature range 40 to 80 degrees. Now, we have not found it possible to assign a single temperature where permanent deformation would be assessed. And that should really be no surprise, because in different countries within Europe they have different climates, they have different high temperatures during the summer. So within the range 40 to 80 degrees, we believe we've captured pretty much most of the climate across Europe. So that's what we've achieved with permanent deformation. Our next performance indicator is thermally induced cracking, which is associated with low service temperature. Here, having looked at all of the available test methods, we've focused on the bending beam rheometer, EN14771, and the parameter that we believe is the best indicator of thermally induced cracking is the critical stiffness temperature, the temperature at which the binder achieves a stiffness of 300 megapascals. When does cracking tend to become a problem? Probably more towards the end of service life. So here we believe that assessment of critical stiffness in the BBR would be best achieved and most relevant on long-term aged binder. Next was raveling resistance. Now, raveling resistance is associated with, I'm sorry, I'm really struggling this morning, is associated with both the cohesion of the binder and adhesion of the binder to the aggregate. Now, it's incredibly difficult to come up with a parameter that deals with adhesion because it's so subjective to the properties of the aggregate and to a certain extent the properties of the binder. So we made our focus cohesion because adhesion was such a difficult area to focus on. And the test method that we recommend is cohesion by force ductility, EN13589. But there was a lot of discussion about the force ductility method, and amongst the members of task force specification, we found that the existing method didn't properly describe the performance of the binder. There was a lot of information missing because when we run a force ductility test, we only ever report the cohesion between 200 and 400 millimeters extension. There's a lot of information in that first part of the curve between 0 to 200 millimeters, and equally there's more information beyond the 400 millimeters. So quite an interesting suggestion coming from task force specifications is that the force ductility method should be modified so that we determine cohesion by integration underneath the whole curve. And that's the sort of thing that you would do in classic tensile testing. You would report the area under the curve, and also you would report the elongation to break. Again, that's pretty important from a purely material science tensile testing kind of perspective. When we looked at raveling resistance, again, we thought this is the sort of thing that tends to happen towards the end of a pavement life, and therefore the cohesion should be determined on long-term aged binder. Now, we appreciate there is not a huge amount of experience on this, but we do believe that it's important that we get the energy under the whole curve and the elongation to break, and we measure that on long-term aged binders. When it comes to stiffness, it's related to viscoelastic behavior, and as we stand, we are not quite there with deciding upon a test method. There's been a lot of focus on equistiffness temperature, and we believe short and long-term aging. When talking about equistiffness temperature, during the review of 14023, there was the potential the suggestion, to include equistiffness temperatures as measured in the DSR rheometer, measuring the temperature at which the binder attains a stiffness of 5 megapascals and of 15 kilopascals. There is also a view within task force specifications that just focusing on the stiffness value or the complex modulus doesn't give you the whole picture, so that we should also perhaps report the phase angle. But we have, as at the moment, we have more work to do on stiffness and how we can best describe it. And it's a similar situation with durability. Durability is related to aging, but it's also related to viscoelastic behavior. And again, there is not quite a full consensus on this, but a majority of members believe that we should look again at equistiffness temperature. So starting with the parameter T0 on unaged binder, temperature where G star equals 15 kilopascals, and then going through those other stages, T1, T2 on short-term aged binder, T3, T4 long-term aged binder. And that will give us a pretty holistic view of the durability of the binder. We start with unaged. We can see the change in stiffness going to short-term aged to long-term aged. But again, there is also the possibility of including within that assessment of the binder, if you like, inclusion of the phase angle, because that will give us some more information. What are our next steps? Well, we are currently in the process of developing a position paper on future specifications, which covers all of those parameters that I've just spoken about. We think it's important that EUB3465 has a clear voice and can give clear guidance to its members, and as a consequence, the position paper is probably one of the best ways that we could do that. Our aim is to have that position paper available for the E&E Congress in June next year. It's currently in its second draft and will be going forward to be assessed by our technical committee later in the year. We will respond and to the outcome of the TC336 plenary, which is actually tomorrow and the following day, and continuing to guide Task Group 14. We will also need to be very, very careful in our monitoring of developments on the construction products regulation and have as much input onto that as we possibly can. Equally, we'll need to look at international developments. It's very important that we don't disregard developments that happen in other areas. We've seen the USA's strategic highways research program and how that delivered the super pave specifications. As a group, both task force specifications and task force test methods will be looking at international developments so that we can continue to have a voice and stay focused on delivering the best levels of specification that are both relevant for our members and give the most appropriate information for anyone that is using our product. And we also need to think about specifications for what I've called the next generation of binders. As we know, there's a big focus on temperature reduction at the moment to reduce the amount of energy that's used, to reduce the amount of emissions that are released from bitumen during mixing. There's also developments on lower viscosity binders. Currently, we don't have a specification for those. And then I'm sure you will all have seen the number of articles in the trade press about biomodified binders and how they can be specified. So we will maintain our focus on those three areas, and hopefully we will make sure that there are no shocks for our members. That's the best way to put it, I think. Where can you go for more information on this, the best place you can go is to the EUB3465 website. There's a whole host of information there on the work of task force test methods, task force specifications, the technical committee, the HSE committee, etc. And there's more information out there. There's health and safety information, and there's our technical position papers and the data collection documents. That's pretty much where I wanted to conclude. If you still want more information, you're free to contact any members of the EUB3465 team. We'll be more than happy to help you out with any questions that you have. And for now, it just remains for me to thank you for your attention.